Good day to you all. I'm Nudhu Sampson here. I welcome you all today in chemistry class. Today our topic is laws of chemical combination, part 2. Laws of chemical combination. In chemistry, laws of chemical combination are for elements and compounds. We have four laws of chemical combination: law of conservation of mass, law of constant composition, or we can call it the law of definite proportion. The third law we have is the law of multiple proportion, and then the last one, law of reciprocal proportion. Students, you have learned these two laws in the previous class. Now today we are going to learn about law of multiple proportion and law of reciprocal proportion. Let's start with the third law, law of multiple proportion, which is our today's topic. In 1803, this law was given by John Dalton. John Dalton was an English chemist born in 1766. He is known for his atomic theory, Dalton's law, law of multiple proportions, and color blindness. Law of multiple proportions states that if two elements combine to form more than one compound, the masses of one element that combine with the fixed mass of the other element are in the ratio of small whole numbers or simple multiple of. For the better understanding of this, I'm going to divide this law into two parts so we can understand it very clearly. First part, if two elements combine to form more than one compound. And the second part will be the masses of one element that combine with the fixed mass of the other element are in the ratio of small whole numbers or simple multiple of it. Ratio. Okay, now student, coming to the first part of the law of multiple proportion. The first law states if two elements combine to form more than one compound. Now we are going to discuss about the example of this law. As the law states that when two elements, we are going to take two elements, carbon and oxygen here. Both of them combine together and form more than one compound. Let's see how carbon and oxygen combines and form more than one compound. When carbon reacts with oxygen, it forms carbon monoxide. And in the other reaction, when carbon reacts with oxygen, it forms carbon dioxide. So here the two elements combine together and they are forming more than one compound. One compound they form is carbon monoxide. Mono means one. Here oxygen is one. Carbon dioxide. Di means two. The oxygen molecules are two. Now we are going to discuss another example. I'm going to take nitrogen and oxygen. As the law states, when nitrogen and oxygen combines together, they form more than one compound. Let's see how nitrogen and oxygen form more than one compound. When nitrogen reacts with oxygen, it forms nitrous oxide. And in the second reaction, when nitrogen reacts with oxygen, it will form nitrogen dioxide. Here again students, two elements combine and they form more than one compound, nitrous oxide and nitrogen dioxide. Student, remember that law of multiple proportion only applies to compounds composed of the same elements only. Let's have a look at this. Carbon monoxide, carbon dioxide. As I have told you before that this law is applied to the compounds composed of the same elements. So, carbon and oxygen obeys the law of multiple proportion. Let's see another example. If carbon dioxide, we are taking a compound, and sulfur dioxide, it will obey the law of multiple proportion or not? No, it will not obey the law of multiple proportion as both of the compounds are different. If I take an example of H2O, water, H2O2, hydrogen peroxide. Are they going to obey the law of multiple proportion or no? Yes, they obey the law of multiple proportion because the combining elements are the same.
Start.
Now coming to the next part of this law, the masses of one element that combine with the fixed mass of other element are in the ratio of small whole number. Masses of one element that combine with the fixed mass of other element are in the ratio of small whole numbers. Here I am going to take the example carbon. When carbon reacts with oxygen, it will form carbon monoxide. When the carbon reacts with oxygen, it forms carbon dioxide. As the law says, masses of one element that combine with the fixed mass of other element. Here, the mass of carbon is fixed, and that is 12. And the mass of oxygen will be 16. And here as we have the two oxygens, so 16 multiplied by 2, it will comes 32. So if we calculate the masses of these compounds, so the carbon is 12 and oxygen is 16. Here we have carbon 12 and oxygen, as we have calculated here, 16 into 2 is 32, so it is 32. 12 is to 16 is the ratio of carbon monoxide, and 12 is to 32 is the ratio of carbon dioxide. Okay students, here you can see that the mass of carbon in both here is the same, 12 and 12. The difference is between 16 and 32. So we are going to take out the ratio of 16 and 32. 16 ones are 16 and 16 twos are 32. So 1 is to 2 is the ratio over here. As we have discussed it before, or I'm telling you, the law says that masses of one element that combine with the fixed mass of the other element are in the ratio of small whole numbers. Now we are going to discuss another example for this law. Let's take hydrogen and oxygen. As hydrogen and oxygen will combine, they form two compounds. Those are water and hydrogen peroxide. When hydrogen combines with oxygen, it will form H2O, that is water. When hydrogen reacts with oxygen, it forms hydrogen peroxide. Here, the mass of hydrogen is 1. 1 is to 2 is 2. Here, hydrogen 1 is to 2 is 2. So, the mass of hydrogen is 2. Oxygen is 16. 16 into 2, 32. So, the total mass of these compounds will be 2 into 16, 2 into 32. As the law states, mass is one element that combined with the fixed mass of other element. So here the fixed mass is of hydrogen, and that is 2. So the difference is between 16 and 32. 16 and 32. So if you find out the ratio, then 16 ones are 16 and 16 twos are 32. Again we have 1 is to 2. Ratio of small whole number. Law of reciprocal proportion. This law was given by Jeremias in 1792. He was a German chemist. Law of reciprocal proportion states that when two different elements separately combines with the fixed mass of third element, the proportion in which they combine with one another shall be either in the same ratio or simple multiple of it. Again here students, I'm going to divide this law into two parts so that we can understand it clearly. The first part will be when two different elements separately combine with the fixed mass of the third element, the proportion in which they combine with one another shall be either in the same ratio. And the second part will contain combine with one another shall be either in the sum simple multiple of it. Okay students, now coming to the law of reciprocal proportion. In simple words, we know that the proportion of elements in compound A, B and the proportion of element in compound B, C. We can determine the proportion of elements in compound A, C. Let's look at a few examples to make this law clear to understand. The first part of this law was the same ratio. If carbon and hydrogen, two different elements combined separately with fixed mass of third element, two different elements, I'm going to take carbon and hydrogen as two different elements. They combine separately with fixed mass of third element. So, hydrogen and carbon, two different elements, combines separately with the fixed mass of the third element. Carbon and hydrogen will form CH4, that is methane. H and O, it will form H2O, water. C and O will form carbon dioxide. Carbon is 12, hydrogen 1 is to 4. Hydrogen 1 is to 2. Oxygen 16. Carbon 12. Oxygen mass is 16 into 2 and it will form 32. 12, 1 fours are 4. 3 is to 1. And if you find the ratio of 12 is to 32, here comes 3 is to 8. And here we have 2 into 16. So it will be 1 is to 8. As the law says, when two different elements combine separately with the fixed mass of the third element. Here you notice that carbon ratio comes 3 and here in this compound the ratio is 3 of carbon. And here as we have taken hydrogen, the second element, here hydrogen ratio is 8 and it comes 8. So the compound here formed is carbon dioxide. So we came to know about the ratio of the third element. Second part of the law states simple multiple of it. Simple multiple of it. Two different elements, carbon and oxygen, combined separately with the fixed mass of the third element. Here I'm going to take the third element sulfur. So, oxygen combines with carbon and form carbon dioxide. Carbon reacts with sulfur and form carbon disulfide. Sulfur reacts with oxygen and form sulfur dioxide. Now I'm going to take the ratio of their masses. Carbon is 12, oxygen 16 into 2, and that will be 12 is to 32. Carbon 12, sulfur carbon disulfide, so sulfur mass will be 32 into 2. It will form 12 is to 64. Here we have sulfur 32, oxygen mass is 16 into 2, so it will be 32 into 32. Now we are going to find the simple ratio of them. As the law says, they are the simple multiple of it. So it will form 2, 6, 12, 16, 32. So it will be 3 is to 8. Here it will be 8 is to 8. And here 3 is to 16. Okay students, carbon and sulfur combines in the ratio of 12 is to 64. That is 3 is to 16. 3 is to 16 is the simple multiple of 3 is to 8. Okay students, now coming to your home assignment. You have to do what is law of multiple proportions. Explain with examples. State the law of reciprocal proportion and illustrate it with examples. You have to do your homework or the home assignment on a foldscape sheet. Punch it in a file and submit it at school's gate on every Saturday between 9 to 11 a.m. Stay home, be safe, wear mask, protect yourself and follow SOPs for COVID-19 given by WHO, World Health Organization and Government of Pakistan. See you in the next class. Till then, bye bye.